Hey, ladies and gents, happy Wednesday. Today, we are going to continue to talk about how to undo multiplication, answer the question if this is what I end with, what two binomials or whatever it happens to be, what size polynomial, what did I multiply together to get that answer? This is a continuation of Monday's assignment. So if you have not yet watched Monday's video, then I want you to stop this video, go back to Monday, which would have been, let's see, the 11th, go back to Monday's video and watch that first. This will really not make sense if you did not do Monday's work first. So go back to Monday. If you are ready for today's, then we are, if you want to find where we are online on Agile Mind, my course is on top, Unit 8 on the left, topic 24 down arrow next to lessons, and this is lesson 1. It's really lesson 1 and lesson 2 really cover the same thing. I'm not really going to refer to any of the slides that Agile Mind has right up here that you can see. I'm going to instead focus on what's in the workbook, which is page 355. And if you need that workbook, it is right here. If you are on Agile Mind, underneath topic 24, activity book is right there. So page 355 in that workbook. You may need a calculator just for basic adding, subtracting, multiplying, and dividing. I'm not going to use one, but if you need it, make sure you grab it. Let's flip around my computer here. And here goes. We are going to start page 355. You can see there's an example right there, but I am going to start with number 1. So what we are being asked to do, you can see the heading, you can see it up here, but the heading says area model. We are going to take this polynomial, we're going to factor it. Factors go right here. Factoring, remember, is the appropriate name for undoing multiplication. And then we're going to just check it by multiplying. So we're going to show that we can factor, we're going to show that we can multiply, and within multiplying, we know we have to combine like terms. So running through the process that we learned on Monday. Okay. If you need that X method, we can work out in lists. I'm going to do 2 different methods actually for this first one, and then I'm probably just going to go with that X method. So here we go. First thing we need is factors of 8x squared. There's our little rainbow. So we need things that multiply. I'm going to use the X for multiply to 8x squared. And as we said before, don't worry about the X squared. It just means we're going to throw an X onto our final answer. So let's see, 1 times 8 gives us 8. I'm going to throw in an X on each to get the X squared. 2x times 4x gives us 8x squared. 3 would not work, and 4 is already on our list, so we're done. Next thing we need is a pair of numbers. Oop, I'm sorry about that, you guys. It's my son's glucose monitor, but I can't really make the sound go away. So let's see if I can hide my phone so you don't hear that beeping again. So now that we found factors, things that multiply to 8x squared, we need to find from that list a pair of factors whose sum, aka adds, up to 6x. And that pair of numbers, 1 plus 8 is 9, is obviously going to be 2x plus 4x would give us 6x. So now that we have that, I'm going to grab my black pen over here. Now that we have those, we can work backwards from our box. That's really what they mean when they say area model, is work backwards from our box. So we know that in the very top left, is going to be our A term. In other words, our X squared term. So that's going to be in the top left. In the bottom right is going to be our constant. So those 2 that are attached to by the rainbow are going to be the top left and the bottom right. And then the 2 here are going to be our pair from adding. So 2x and 4x. And the order does not matter at all. If you wanted to put 2x up here, fantastic. Order does not matter. And now we're going to work backwards. We are going to answer the question, what does each column and each row have in common? So looking at this column right here, they don't have a number in front in common because x squared doesn't have one, but x squared, x, there's an x in common. Looking at this column, they don't have an x in common because 8 doesn't have one, but 8 and 4 are both divisible by 4, so I'm going to put a 4 up there. Working on our rows, x squared and 4x, no number in common because there's nothing in front of x squared, but they have an x in common. And 2x and 8, notice 8 has no x, so I can't put an x, but 2 and 8 are both divisible by 2. These things on the outside are what we refer to as GCFs, greatest common factors. But those things on the outside also tell us what we multiplied together, x and a positive 4. And then down the other side, x and a positive 2. It also tells us what we multiplied together to get this polynomial right here. Now, I'm going to go ahead and check this by multiplying. I can check this by doing the box method. Now, since the box is already here, I would say try and stretch yourself in that double distribution or that FOIL method that I talked about before. You could try that as well. I'm going to review what FOIL means, and I'll do box down here as another one. FOIL means I am going to multiply the first terms in each parenthesis. So x times x squared. O means I'm going to do the outer or outside terms. So x times 2 is a positive 2x. I means multiply the inside or the inner terms. So 4 times x is 4x. And L means multiply the last. So 4 times 2 is a positive 8. Now I'm going to look to combine like terms. 2x and 4x is positive 6x's. And I'm going to bring down the two things that did not have like terms, x squared and 8, positive 8. And we can see that, yes, this matches what I started with, which means these factors that we came up with as a result of doing this backwards box or backwards area model are correct. These are the two factors that must have been multiplied together to get this trinomial of x squared plus 6x plus 8. So I am going to run through 3 more examples. I'm going to do some organization a little bit different each time, and you can really choose what fits you the best. Many of you really, really liked this setup that we did those X method problems way back when. We started them way back when. You can do it this way too. So here we go. I'm going to do the X method instead of this list version this time. So let's see. 10 times x squared, 10 x squared. I need a pair of numbers, and I'm just going to remind myself by putting a time sign down here. I need a pair of numbers that multiplies to 10x squared. At the same time, I need a pair of numbers that adds, and I'm just putting the plus sign again as a reminder, that adds to 7x. Now, the only downfall of this method is that there's no room really for a list of listing out what multiplies to 10 and adds to 7. So this method would be really good for those of you who have your mental math facts really quick and really at the tip of your tongue. Those of you who need that visual, I would suggest doing a list. So I know that 1 times 10 is 10, but it doesn't add to 7, but 2x times 5x would give me the 10x squared, and it also adds to 7x. Sorry, I can't make that alarm not go off. Hopefully it'll slow down here. So moving then to our box. Here is our box. Top left is going to be our 2 connected by the rainbow, our x squared term, and bottom right, our constant term. And the 2 on the diagonal are 2 chosen terms right here. Any way you want to put them, doesn't matter which one goes where, 2x and 5x. And then we are going to work our way every column and row and answer the question, what do they have in common? In other words, what are their GCFs? So 2x and x squared have x in common. 5x and 10 are both divisible by 5. Looking at our rows, x squared and 5x are both divisible by x. 2x and 10 are both divisible by 2, which looking at the top and the side of my area model, my box then, my factors must be x plus 2 from the top and x plus 5 from the side. We just came up with what did I multiply together to get x squared plus 7x plus 10. In other words, what are the factors of this trinomial? Now, again, we're going to check by multiplying. If you like this distribution model using the acronym FOIL, go for it. I'm going to use the box method this time, which I know is a little redundant based on what's over here, but I just want to show you your options. So I'm going to set up my box, and the only thing I'm going to do different than what's over here is I'm going to switch the sides, switch the order on my box a little bit. So x plus 2 was on the top before. I'm going to put it on the side just to show you it doesn't really matter. And I'm going to put the x and the plus 5 on the top. Now, I put plus signs here. They weren't here before. It's okay. We assume things are positive, even if the plus sign's not written. So it's really up to you. So here we go. I always start in the bottom right because it's always the easiest. 5 times 2 is 10. Then move anywhere you want. 2 times x is 2x. X times x is x squared. And x times 5 is 5x. Now we know we never answer in a box. We're going to pull everything out of that box. X squared plus 2x plus 5x plus 10. And we're going to look for like terms right there in the middle. 2x plus 5x is 7x's, positive. So I'm going to leave a plus sign, and we're going to bring down those that did not have any like terms. So x squared plus 10. And comparing this trinomial because there's 3 terms, to this one, I can see they're the same, which tells me, yes, these are the factors of x squared plus 7x plus 10. This is what I multiplied in order to get this trinomial. Okay, so notice everything we've done so far has had only positive signs. So I'm going to flip the page to page 356, and we're going to do number 4 and number 6 together. We're going to do 2 more, and you can probably see my side writing here that 3 and 5 are going to be your homework. But stay with me. It's probably great to run through 4 and 6 because, again, they have some minus signs. And if you glance ahead at number 6, there's something missing in there. Okay. So again, it's up to you if you want to do that list method or the X method. I'm going to do one of each, kind of up to you. So I am going to do the X first. It's really whichever method you like. And here we go. I need a pair of numbers that multiplies to give me, notice that negative, I need it, negative 8x squared. And if you need a little reminder that that's multiplication, go for it. And I need a pair of numbers that adds, I'm going to put a plus sign to remind me, adds to a positive 2x. Okay, so I'm going to think of things that multiplied 8. I'm going to ignore the negative right now. 1 times 8 or 2 times 4. But the pair that's most likely going to give me a 2x is going to be the 2x times 4x, because again, 2 times 4 is 8, and 2 and 4 are 2 apart. But right now, 2 positives multiply to a positive. In order for me to multiply to a negative, I'm going to have to make one of these negative. But being really careful to know that once I make one negative, I still need to add to a positive 2x. So I'm going to put my negative on my 2. Negative 2x's plus 4x's is positive 2x's. And negative 2x times 4x is negative 8x squared. Okay, so now that we have our terms, we're going to go to our box. And we're going to place everything inside of our box. Our 2 connected by that little rainbow, our squared term and our constant term. Make sure you leave a negative with that 8. Go on the diagonal, top left, bottom right. And our 2 chosen terms, again, in any order, are going to go into the remaining parts of our box. And now we are going to work backwards to do some factoring. What do they have in common? What are the GCFs? So x squared and negative 2x have an x in common. I'm going to go in a weird order here. X squared and 4x have an x in common. This column, 4x and negative 8, don't have an x in common because 8 doesn't have one, but negative 8 and 4 are both divisible by 4. And looking at this last row, notice they're both negative. That tells me, hey, they have a negative that's in common. They don't both have an x, so I can't put x, but 2 and 8 are both divisible by 2. So now that we have filled out what do they have in common, what are our GCFs, greatest common factors, that means x plus 4 from the top and x minus 2 from the side must have been what we multiplied together to get x squared plus 2x minus 8. This time I am going to check this one using FOIL. So here we go. F is first. X times x is x squared. O is outer or outside. x times negative 2, sign in front is really important, is negative 2x. I is inside or inner. So 4 times x, which is a positive 4x, no negative signs included in that one. And L is last. So again, sign in front, negative 2 times 4, which is negative 8. Now that we've multiplied, we're going to look to combine like terms. Notice again, they're in the middle. Negative 2x's plus 4x's. And if you're not great with your mental math or not confident, you can use your calculator. You won't type in the x's. The x's just tell us, hey, they're like terms, but you would type in negative 2 plus 4, which is 2. They had x's. I'm going to bring down what they didn't have in common, negative 8 and x squared. And comparing, yes, this is exactly what we started with. So if somebody tells you, a teacher tells you, hey, you need to factor x squared plus 2x minus 8, yep, x plus 4 times x minus 2 are the correct factors. Okay, last one I'm going to run through with you today is number 6. And like I said, number 6 looks a little bit different. Number 6, if I rewrote this one, we are missing our x term. So we have x squared, we have minus 9. What we are missing is our x term. So why would we be missing our x term? How many x's would we have to have in order to really have none? Oh, well, that makes sense. We have 0 x's. So I'm just going to insert that 0x just to help us through this whole factoring process. This time I'm going to go ahead and do the list rather than the x method. So negative 9 times x squared. I need things that multiply, factors of negative 9x squared. So here we go. We're going to do our list. Well, let's see. 1x times 9x would give us 9x squared. I will worry about the negative once I have my list. 9 is not even, so 2 does not go in. But 3x times 3x gives us 9x squared. We'll worry about the negative later. 3 is already on the list. We're good. 4, 5, 6, 7, 8, not going to go in. I also need a pair of numbers that add, and this is why I needed to write that 0 in there, that have a sum or add to 0x. Okay. Well, think about what adds to 0. In order for something to add to 0, I need opposites. So I need like a 5 and a negative 5, a 12 and a negative 12. Opposites cancel each other out and combine to give you 0. Well, the only place I can potentially have opposites is right here with the 3. I just need to make one negative. I need a negative 3x plus a 3x. Opposites add together. They cancel to give you nothing. And if one of them is negative, then negative 3x times positive 3x is going to give me that negative 9x squared. So in other words, if I am missing that b term, that term that's in the middle, that x term, I know I'm going to have opposite factors. Okay, moving into our box then. I'm going to create our box. Our x squared term, the 2 connected by the little rainbow, x squared term, and our constant term. Don't forget that minus that's on it, negative 9. Then we're going to fill it in with our 2 chosen factors, any order, negative 3x, positive 3x. And then we are going to work to the outside to identify what do they have in common, what is our GCF. X squared and 3x have an x in common. Negative 3x, negative 9, they're both negative, and 3 and 9 are both divisible by 3. Columns, x squared, negative 3x have an x in common, and 3x and negative 9 are both divisible by 3. This time I am not going to write the negative because the 3 doesn't have it. So that means looking on the outside, my factors should be x plus 3 and x minus 3. And this time I'm going to double check it using the box method. You can do FOIL if you like FOIL. And what I'm going to do, sorry, my boxes keep getting smaller. What I'm going to do to check the box method, like the last time I did it, I am going to switch the order of my factors. So we had positive 3 up here. So I'm going to do positive 3 down the side and my x minus 3 up on top. and we are going to multiply to fill in our box. This is just our check. So here we go. X times x is x squared. X times negative 3 is negative 3x. Positive 3 times x is a positive 3x. And positive 3 times negative 3 is negative 9. Again, we never answer in our box, so taking everything out of our box in any order you wish, x squared minus 3x, a positive 3x, and a negative 9. We're going to look to combine like terms right there in the middle, but notice they're opposites. What do opposites do? They cancel. Well, Mrs. P, don't we write the x? No, because if we write the x, that signifies we have 1, and we definitely don't have 1x. So what we are left with is x squared and minus 9. And if we look, hey, yep, that's exactly what we started with, which tells me these are the correct factors of the binomial because it's two terms, the binomial x squared minus 9. So as you guys can see, today is just a review again of what we did on Monday's lesson. I threw in the extra check, which should also help solidify your multiplication. Your homework, it's listed out on Canvas as well, and you saw it on here, is going to be 3 and 5. You are, yes, going to identify the factors. Here's where your work for the factoring is, but you're going to identify the factors, and yes, I want to see the check. I don't care if you like this method for helping you factor or if you like the X method. You choose whatever works for you. Try one of each if you don't have a favorite. I don't care if for checking you like this FOIL method or you like the box method. You choose. It is completely up to you. But I will tell you this factoring, this special multiplying and the undoing of multiplication is going to be something you will do every single year in math. So practice, practice, practice. And I will also let you in on a little secret. It is the last new thing we are doing this year. So get to work. Let me know if you have any questions.